So now that we got the shell of our game working in the last video, in this video we can actually make the guts of the game, which is going to be the queue. That's going to be used for, in conjunction with a timer, is going to be used for doing our BFS algorithm. So let's declare a queue here, and there is a data type called a queue built into .NET, and it's a generic class, so that means we have to supply the data type for the queue in the angle brackets, and it's going to be a queue of points, and I'm just going to call it queue equals a new queue of points. And it's just going to, if I just hit the tab key, it'll autocomplete for me. There we go. And I'm going to need to keep track of two things here. So let's go back to the little demo, and you can see here in my game, in this game here, when I click on one of these squares, I'm going to be replacing all of this color that is reachable with this color. So this is like, I have to keep track of those colors. So this is going to be the old color, and whatever I click on will be the new color. So we need to make some variables for that. So let me make an integer called old color and new color. And then I've also added a timer to my form that I did between, that I sort of did after the last video. So what you want to do is go to your form and pull up the toolbox and drag a timer control onto your form. And I've just left a thing called timer 1. It's not enabled, and I set it to 100. We can play around with that later. Maybe that's too fast. And then you want to double click on it to have Visual Studio create the little timer callback for you. All right, so now that we've got those variables and our timer, now we can actually start implementing the dependencies that we're going to need for our project. So the first one I guess we'll work on is let's do some of the easy ones first here. Let's write a function to determine if the players won the game. That's an easy one. So so I'm just going to call that bool 1, or how about player 1? There we go. And this is going to check to see if the board is all one color. All right, and that's easy. So I'm going to use two nested loops, and I'm going to compare every square to the top left square, and if they're different, well then the board isn't all one color. That's very easy to do. So all I'm going to do is I'm just going to grab those nested loops from another one of my functions and paste it in here. And what I can do is say if the color code of the board at ij is not equal to the color code of the board at 0, 0, well then the player has not won. So let me get rid of that, and then change this to 0, 0. And then, so if I get to the end, if I get past my loops, that means that that means I didn't prove the player hadn't won, so the player must have won. There you go. So if I haven't bailed out here, then the player must have won. All right. What else? What other easy functions do we need to do? Well, in order to keep our game from getting caught in these little circles, we've put this property on all of our squares called filled. And before we start one of our bucket fills, we want to set all of those to false. Otherwise, the game will work the first time, but not the second time. So let's make a function to just set everybody's filled flag back to false. Maybe I'll this won't be a void. This will be a void function. I'll just call it reset squares. And again, this is just nested loops, and all I have to do is just set everybody's filled flag to false. There's no if statement in here at all. There we go. So now I have set all of the squares back to false, and now I can start bucket filling them again. All right. So now we need a function that is going to put things in our, well, let's look at this function, this flow chart up here. So the way our BFS is going to work is it's going to be driven by a timer, and when the timer ticks, we say, is our queue empty? If it's not empty, if it's got something in it, we're going to pop out the first thing in the queue, we're going to bucket fill it, and then we're going to put its neighbors into the queue so that they'll be bucket filled. Now when we put the neighbors into the queue, there's a couple of checks that we have to do. We have to make sure, okay, have they been filled already? Well, if they've been filled already, we don't want to bucket fill them again. If they're the wrong color, then we don't care. We don't want to bucket fill them. And if they're off the board, then we don't want to bucket fill them. So if you go back to the little game here, if I click on a square, what I want to do is replace all of this color with this color. So if the new fill color, if a square, I am only replacing squares that have the original color, right? I'm not replacing anything else. So I want to ignore those as well. And I have, so in the flow chart here, we've got, okay, so we have to check, is the coordinate we're trying to fill on the board? If it's not, ignore it. If the color is not the old color, ignore it. If the square has been filled already, ignore it. Otherwise, then we're going to queue it up. And then we're going to mark that it's been filled. It may not have actually gotten filled yet, but it's either been filled already or it's in the queue waiting to be filled. So we need to keep track of, hey, this square's already been handled. Don't try to handle it again. So let's go write this function, the inQueue function. And we're writing this first because we want to get to writing this timer tick function. This is the guts of the whole thing. Which is, it's not a lot of code. This is in our timer tick. That's where we're actually doing our BFS. But that requires these little dependencies that we just wrote. So we need to be able to see, did the player win? And we need this inQueue function. And we need our reset function, which we already wrote. So let's go write our inQueue function. And what'll it'll take? Let's see, void inQueue, and let's say it takes a point, and we'll call it p. So let's check to see if p is on the board. So if p's x coordinate is greater than or equal to 0, and p's x coordinate is less than the width, not white width, and p's y coordinate is greater than or equal to 0, and p's y coordinate is less than the height of the board. Okay, so that's good. So the coordinates are good. And then let's make sure that it hasn't been filled already. So if the board at this coordinate, p dot x, p dot y, has not been filled, then we need to check to see, is it the right color? Like, is the color of this square the color of the squares that we're replacing? So let's say if the board at that coordinate, I could just copy and paste all that actually, dot color code is the old color, then we want to put it in the queue. QUE.E, okay, dot. Now, how do you put something in a queue? There's no add function. Add is for list, but there is an enqueue function and a dequeue function. That's what we're going to be using. So let's put in a point. Well, let's put P in the queue. There we go. And then we should also mark that that square has been filled. It may not have gotten filled yet, but it will be. Or maybe, so we just want to make sure that that square doesn't kind of get double counted. So let's go into the board. Oh, I've got it right here. Equals true. There we go. So there's our enqueue function. And now I think we have everything we need. We've got all our dependencies. Let's go look at our flowchart. Is the queue empty? Pop the first thing. Change its color. Enqueue its neighbors. Redraw the board. Okay, so that's good. And then otherwise, the player wins. Yeah, we've got all this stuff. So now we can go write our timer tick function, which is this guy right here. Let's go write our timer tick function. Okay, so what are we doing? We're checking to see if the queue is empty. How do we do that? We check its count properties. It's count greater than 0. Else, tab. There we go. What do we do if the count's greater than 0? Well, we pop a point out of the queue, or we dequeue. We dequeue an element from the queue. We pull an element, the first thing out of the queue. Queue dot dequeue. There we go. Pull something out of the queue, and if I hover over this, you'll see it says removes and returns the object at the beginning of the queue of type T. Okay, so that means not only have we now accessed that element, it's also been removed from the queue as well. So now what we want to do, this is where we're doing our BFS algorithm. Change the color. Put the neighbors in the queue. And redraw. Okay, so that's what we're doing here. So how do we change the color? Well, the color of this square is now the new color, right? That's the color we're bucket filling with. So the board at p.x, p.y, color code equals the new color. And how do I put the neighbors in the queue? We just wrote a function to do that. So let's put that guy in the queue. So how do we, this enqueue function takes a point. So we're going to have to take our, make our point structures that represent the neighbors of this guy. And what are the neighbors of this guy? Well, let's go to the document. And you can see, so if I have a square that's at xy, I've got x, y minus 1, x, y plus 1, x plus 1, y, x minus 1, y. So those are the 4 points. So let me make new point structures here, x minus 1, y. Now watch to see it automatically puts in the, oh, it's going to be p dot. There we go. So take the point that we just pulled out of the queue and use that to make a new point that's 1 to the left. And then let's take that and make 1 to the right. And then we'll make 1 up and 1 down. Minus 1, plus 1. And let me get rid of those guys. So now I've enqueued the neighbors of that square. Now remember, if they've already been bucket filled, or they're already in the queue, or they're off the edge of the board, or they're the wrong color, then they're going to get ignored, right? So this enqueue function is doing a filter for us. It's not just kind of blindly throwing all the neighbors in there. Otherwise, it would just bucket fill everything and then run off the edge of the board. And then redraw. How do we redraw? Picture box 1 dot. We could call invalidate. What we really want is refresh. We want the draw to happen immediately. Invalidate will queue up an event, and there may be a slight delay before it actually happens. And we want to see the trickle effect happen without kind of stuttering and stopping. We want to see it happen smoothly. We want to use refresh rather than invalidate. So let's go back to our document and just see that we actually did what we were supposed to do. So is the queue empty? No. Pop the first thing, change its color to the new color, and queue the neighbors, and refresh the control. Okay, great. So we did that. Is the queue empty? What was the other thing? Stop the timer, check to see if the player won, and if they did, pop up a message and reset. Okay, easy. If player won, whoops, message box.show you won. Oops, and reset. So message box.show will kind of monopolize the interface. It'll lock up the interface. This is called a modal dialog. It will kind of take over until you dismiss it, at which point it will call the reset function. Now our reset function doesn't actually redraw the board, so we probably want to, after we reset the board, we want the player to see that the board has refreshed. So we'll call invalidate, and that's it. That's our timer tick function right there. That's the that is the whole BFS algorithm right there. Pull something out of the queue, do something to it, and queue its neighbors or its children or whatever the context is, right? So this is actually a very useful algorithm for path finding the shortest path through a graph. So there you go. And that's it. Okay, so now let's kind of wire this up into our interface. So that's going to be our, where's our mouse click function. So what we want to do is, if we go back to the game here, when we click on a square, we want to save the color of the square at 0, 0. We want to get the color of the square where the mouse was clicked, and then we want to kick off our bucket fill algorithm. So that what that means is we're going to save these two colors. We're going to call that clear function, the clear squares or reset squares function, so that all of those marks, all those little flags go away on those squares. Then we're going to put that first node in the queue, and then we're going to start our timer. And I've got this worried feeling though. Okay, so back to the timer 1 tick. I can see I forgot to stop the timer. So that's going to be timer1.stop. Sorry, you know, you probably saw that. I went right over it. There you go. Okay. Otherwise, it's just going to keep ticking, and I don't know. Maybe bad things will happen. I don't know. But we want to shut off our timer. All right. Back to the mouse click. So let's get the old color is going to be that's very easy. That's the board at 0, 0's color code. All right, and then let's get the new color. That's going to be not at 0, 0. It's going to be at the mouse, wherever the mouse was clicked. And we have to scale that down to array coordinates. All right, and then let's call our reset squares function. And you know what? If the new color and the old color are the same, let's just bail out. Or let's put a guard around this. If the old color does not equal the new color, then, because otherwise it's like the player's just wasting a move. Reset the squares. Okay, so now what we want to do is put a new point into the queue. So let's say in queue, let's call our enqueue function and say new point 0, 0. And I spelled enqueue wrong. There you go. And then once we've done that, timer1 dot start, and then maybe we want to say, you know, at what point do we actually want to subtract 1 from turns? I don't know. We haven't really thought about the turns yet. Maybe we'll do that at the very end, but we can say turns minus minus. And then let's put that in the picture box here. Oh, and then we probably want to say something like maybe we can handle that here. And turns greater than 0. So you've got no wait, are we starting at 0 and counting up, or starting at 0 and counting down? I don't know. Let's count down. Yeah. Okay. So if turns is greater than 0, that works. And then we've got let's put that in our text box. Text box 1.text equals turns dot to string. All right. Yeah. All right. Let's just see if let's double check the documents here, and then maybe we'll try this. So here we go, and if I click on blue, so it puts blue in the queue. Okay, so now let me try to grab that yellow. So I'm going to click on the yellow, and see a bucket filled it with yellow. And now let me try to grab the blue again. So you can see that it's working. Now let me try to grab this stuff. And let me try to grab the red. So you can see it's doing the BFS algorithm. Seems to be working. Now, I think we might want to speed it up just a little bit. So if I go into my my timer here, and maybe change this down to like 25 or something and run it. All right, let's see what effect that has. That's pretty fast. It's not really taking into account whether or not we've lost or not. So I guess, do we have a reset function up there? So it says I have, and when I get down here, can I click anymore? I can't click anymore. Nope. So I'm done. And then if I want to reset, why doesn't my reset work? All right, let's go figure that out. So reset. Let's go to my form and open up reset. So there's my reset function. I guess what I need to do down here, I guess maybe I really do need to do the invalidate here. Picture box 1 dot invalidate. And then also let's set our turn. And then we did set the turns back to 25, but we probably want to update the picture box or the text box as well. Text box 1.text equals turns dot toString. There we go. Because everything in the .NET world has toString built into it. So let's go test that out. And we click, 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 and I'm done. So let's try to reset. Hey, it works. Neat. So there's our little bucket fill game. Really cool use for the breadth first search algorithm, the BFS, which requires a queue, and that's it. Nothing more than a queue, and you get to play this fun little game. All right. Well, I hope that was somewhat entertaining. If nothing else, you got this fun little game to play out of it. If you have any questions, just let me know. Be happy to answer them.